Alright guys, like so much of mathematics, a lot of what we do is based on kind of going backwards from the normal way of doing things. That's in fact what all of algebra is. All of algebra is, I don't know what I had at first. Let me work backwards to figure out what I had. Right? That's basically all of algebra. It's a little more, but that's basically. So, if I have this function, and I have this function, what is this? In what way?
It would be the square root of x squared
Yeah,
minus 2.
you take this and you put it in, right? Because you can even write this as f of x squared minus 2, and that just means whatever the hell's in here. Sorry? What? Say again?
No, it's
X squared minus 2.
over the square root.
Sorry?
Over the square root.
I didn't say divide anywhere. You mean square root over that?
Yeah.
Okay. Yeah, because you will just, what does this mean? What does this always mean? Whatever's inside of the function, we put it in place of the x. So what am I putting into f? G. So what is g? This. So what am I putting into f? This. So put it in. Alright. So going that way has to be desperately easy. Whatever is inside the function, you put it in, right? In place of x. So be with me. That's got to be where we start, because if you can't do that, you ain't ever going to be able to do this, right? Because this is that backwards. But that's all functions are. At the heart of them, all functions are is whatever's inside, put it inside. So if I ask you, what's the inside function? What did I just put into something else? What function did I just put into something else?
G of x?
Yeah, this guy, x squared minus 2. And I put it into a square root. So do you see how, kind of like this problem? This problem. What's the inside function?
X minus 1.
X minus 1. So that's going to be what I put in, because that's the inside function. What did I put that function into? Cube root. If I take this and I put it in there, because the whole point of this section is break this up into some function that was put into some other function. Well, if I put this function into a cube root, I get this. That's it. That's all it is. What did I put into what else to create what I see here? That's all that section is. I need you to see that. So it's nowhere near as difficult as it might first sound, but it still isn't like easy. I don't want that to, right? It's in the middle there somewhere. It's definitely harder than just throwing shit in, because you have to think backwards here. What did somebody throw in? So a problem like number 33, doesn't it look gross? But that's easy as shit. What's inside?
3x minus 2 over x plus 5.
Yeah, so that would be g of x. And what is it inside of?
The fourth root.
It's inside of a fourth root of something, right? So if I put this in here, I get this. That's the question. That's the question of that section, is just doing that thing backwards. Here's the result. How the hell did we get there? Right? Maybe. Of course, everybody at home, you didn't see that. There's what we just did. Okay. There's a lot of you at home today, it looks like. All right.
Hungover from football.
Could be. Did it come out the way you wanted, everybody?
No.
I didn't think so. Sorry.
I didn't
It was a
really
good game, though.
root
I
for
really don't
anybody,
give a
but
shit, to be honest.
My wife wanted
I used to be about
Holmes
football.
to lose because he just keeps winning and winning.
See, I'm just tired of the Chiefs.
Oh, I see.
They're
I
becoming
understand.
the new Patriots.
I understand. I've always hated the 49ers. I didn't live in California forever, so I came from the outside world. Came here, and I didn't like the 49ers, and I still don't. I really didn't care, though. I did not care. Yes? Which one? 3-2 number 32 number
55.
55.
Could you do 60 after that one too?
Yeah.
Same section.
Okay. Remind me in a minute here. Let's see. Anybody sad that I moved the test to Wednesday?
No.
So this guy here, right? This is ocean. This is another graphing problem. This guy?
Yes.
So there's some work you can do ahead of time to get ready for what it wants you to do. I'm not bring my calculator, so. Oh, it tells you. Oh, okay. Okay, so this is two problems in one. For a minute, I thought it told you everything. So this is like part A, and this is part B. You guys with me? There's no way to have two x-axes at once. So that's step number one, is to understand they're asking you two questions actually, right? Real quick, guys. If my inputs go from -0.5 to -0.1, how do I determine what my outputs go from to? Plug them in, right? You guys with me? So like, figure out what, I'm gonna call this f of x just because. Figure out what f of -0.5 is and what f of -0.1 is. And this will be the range. In your calculator, how do you tell the calculator, this is my domain, this is my range? Again, I didn't bring them all with me, but I'll put it up here. Does anyone remember how to tell the calculator where to look?
Is it window?
Yes. I gotta remember my access code for the thing, but oh well. Look at that. There we go. Alright. Oh, Jeff's hands are all blue. So if I put in here, what was it again? I'm sorry. 1 over x squared?
Yeah.
1 divided by x squared. And I want to change the window. What's the name for this? What's the algebraic name for what this means?
The minimum value?
What letters are these?
Domain.
What axis? Yeah, domain. That's the domain, correct? That's the smallest input, largest input, correct? So if you know the domain, and you do, they tell you the domain is from -0.5 to -0.1 in that first part. You with me?
Yeah.
So x min would be -0.5, x max would be -0.1. How do you figure this out? We already talked about
That's the
it.
range.
Yeah, that's the range. That's when you plug shit in. Be very careful. Make sure when you plug stuff in, don't just blindly put the numbers. It's got to be small to big, of course. That's why it's min and max. You guys am I with me? Let me ask you this real quick question. When you square something, well, this will turn around when you do it, but when you square something, is it always bigger?
No.
Why not? Give me
Because
one that
sometimes
does.
it's a fraction.
Beautiful, right? If I square something between 0 and 1, the output will be less than what I started with. Are you guys with me? That's why the parabola starts off lower than a straight line, because the outputs are smaller than the inputs. But then at 1, it takes off. Because once I put a number bigger than 1, it's just going to grow. Are you guys kind of with me? A number between 0 and 1, if I square it, it's sort of like taking a percentage of a percentage. And that gets smaller. Yes? Maybe. Do you need to know all that? No.
So that's how you get that.
You guys semi with me? So can somebody tell me, you got your calculator, what is 1 divided by -0.5 squared? Get out of here.
Can you say it one more time?
1 divided by, and the smallest input they wanted me to use was -0.5. So I'm just going to put it into the function. 1 divided by -0.5 squared. Yeah, you should get 4, yeah. And what's 1 divided by -0.1 squared? It's basically 1 divided by 1/10, which is the reciprocal of 1/10, which is 10. 4. 100 at because they didn't square it. Good job, John. So then your range, your Y min and your Y max should be those. They tell you the inputs they want you to use. So therefore, you know X min, X max. You know what to put X min, X max. That's the domain. How do you figure out what to put Y min, Y max? That's the range. Plug the domain stuff in. So now I want to go from 4 to 100. Yes?
So the numbers that gives you the -0.5 and the -0.1, do they both go in on the X part?
Beautiful. That's a single interval. It can't exist on both axes. That's the inputs, right? How did it phrase that again? I can't remember. Just to make sure we're talking the same language. Okay. Yeah. 2 giveaways. Well, 1 giveaway. It says determine the range. Therefore, this must be the domain. But when they say on the viewing window, that's really poorly worded. It's just poorly worded. So great job, book. And again, this book costs you how much? So. This is the domain. They want me to figure out the range. And one thing that might throw people off, because it threw me off for a second, was that these are 2 different problems. Right? Do it for this one, do it for that one. Yeah.
So simply we're going to just plug in 0.1. Well, that's the
Yeah, plug in negative 0.5 like we did, and plug in negative 0.1. That's why I did
Wait,
this
what about
stuff.
the next one that said 0.1 and
That's part B.
RB?
So I'm not done with part A. So those are 2 separate problems.
And that's seen as just the domain, the X dot. Those are
Yeah, here's the domain, right? Negative 0.5 to negative 0.1.
Yeah, but that's an X and Y value as well.
No. Did they write this as a point? Is this a point?
It's just a point, okay.
Is this, no. Is this a point? Is this a point?
Not sure.
It's
What's a point always have on the outside?
parentheses.
Parentheses, right? Is this a
so that-
point?
Yeah, it has the brackets, yeah.
That's an interval. Even if it was parentheses, could it be an interval?
Yes.
Totally, it would just be an interval that doesn't include the endpoints. So there's a lot of, I don't know if you guys understand this. Just like language. Are there a lot of words that are weird? Why the hell did we pick the word? You guys with me? All right, is there some choices we made in mathematics that were kind of weird? Yeah. It sucks that a point could look like this and an interval could look like this. That sucks. Oh well. I wasn't around when they did it, so it kind of stuck. But this one's really a giveaway. This is very much interval notation. So this is the inputs, and you can plug them in to get the outputs to figure out what Y min and Y max are. So when you do this kind of problem for your homework, just do a rough sketch of what you see. You with me? Or if you're really, really like crazy overachiever, you can print out what you get if you know how to do that and attach it to your work. I don't need that. You can just give me a rough sketch. Don't just go, yeah, I did it. just give me a rough sketch. That's all. Yeah.
So how we know which is which? We were given an out.
Do it. Which? How do you mean? Sorry.
So like you said, both intervals and points can be in.
It's got to be from the context.
Yeah. So we're given the output here, so that then now we know that in those brackets is an input.
How do we know? Is
No,
that-
I'm just
Oh,
verifying.
yeah. This is obviously an interval. Couldn't be a point.
Yeah.
So we're not talking about x, y. We're talking about this x to this x. That's a domain.
The difference between an interval and, well, I know what a point is, was the exact definition difference between an interval and a point.
So a point exists in how many dimensions?
One
Nope.
or many, I don't know.
Nope. Well, it could, but a point for us. X is one dimension, left, right. Y is the other dimension, correct?
Yeah.
An interval exists in one dimension. It could be on the x-axis from this value to this value. It could be on the y-axis from this value to this value. You guys kind of with me?
So for the interval, we're just pretending there's just one straight line, which is x.
We're not pretending.
Or, well, it is.
It just is. Yeah. Yes.
I'm kind of confused how to graph that on the window then.
Okay. I don't necessarily want to do your problem for you. Let's look at this one. Okay. Can we figure out the range for this one? What would you do to figure out the range? What's the domain for this problem?
Zero
Point
point-
negative 5 and
Yeah, so this will be X min. This will be X max. I like it.
What about the second part?
Part B, let's do part A. Right, they want me to graph it on that viewing window and that viewing window. And of course, I can't do both at once. I've only got one window, right? That'd be nifty to have a calculator with like 2 monitors, but no. That's getting a little too much. Is everybody with me so far? So again, part of this is translating the Mathish to English. So that part I understand. And that's why I need your help. That's why I want questions from you. Because I know Mathish, and I'm not exactly sure what's not making immediate sense to you. Now, I agree. This is not well worded. This could have been worded better. But now you know when they say graph this on the viewing window, blah, that's domain. And another reason why I know that's domain is because they tell me to figure out what the range is. So I must know the domain then, right? Can somebody help me? How do I figure out this range, given that domain?
Plug in the minimum and the maximum value.
Yeah, so what's, when I plug in a negative 0.5, what do I get? 2, negative 2. And when I plug in a negative 0.1, what do I get? Negative 10. So what's my Y min gonna be?
Negative 210.
What's my Y min gonna be?
-2, or, sorry, -10.
Yeah, that's the smaller one. This is what I mean. And that's the bigger one, yeah. You guys with me? Huh?
Smaller one, 10 is bigger. Alright.
I agree 10's bigger than 2.
I mean, it's smaller.
Negative 10 is smaller than negative 2, yeah. I'd rather have $10 than $2. I'd rather owe $2 than owe $10. So this is smaller than this. This is a worse situation. Yeah. Okay. So coming back to here. Ready? Everybody play along with me. Put it in here if you have a calculator, sorry. 1 divided by x. You got all kinds of shit around me. Now I want to go to window. And the range they gave, the domain they gave me was, what was it, negative 0.5 to negative 0.1, right?
Yeah.
And we just figured out what we want Y min and Y max to be, correct? What do we want Y minimum to be? Negative, say it again.
2.
No, no, no.
-10.
Y minimum, negative 10. Yes?
What it already is.
Love you guys. So do you all agree with me that those are the outputs that I got for the 2 extreme inputs?
Yeah.
You all agree? So therefore, this should be the range, and the minimum is negative 10 for damn sure, right? That's the smaller one. And then what's the bigger one?
-2.
Minus 2. All right, so everybody that wants to play along, play along? Yes.
I think something's
Say again,
weird
sorry.
with mine. It just comes up as an error.
Oh, does it say go to?
Yeah.
Oh, you might have put a minus instead of a negative. Go to the go to option, hit enter, and it'll put the cursor on the problem. So
Why
real
do I
quick,
put negative then?
Here,
negative is at the bottom of the
Oh,
calculator.
it's right
here.
Yeah.
this is button.
So remember, one of the first things I told you about it, there's a minus button and there's a minus button and there's a negative button. It's just the way they had to hardwire the calculator. Yeah. All right. So everybody who wants to play along have this stuff.
Yeah.
Now if they hit graph, there we go.
Okay, that was my problem.
So then you would just kind of copy that. Just give a rough sketch of what you see. Okay. Why don't I see the axes? I don't see the x or the y axis. Why not?
All in there.
X-axis, if I'm on the x-axis, what's the value of y? Give me a point that's on the x-axis. Any point that's on the x-axis.
0.
That's not a point. Give me a point that's on the x-axis.
0.
A point.
1, 0.
1, 0. All right. All right. What happened yesterday? So, a point is 2 parts. So yeah, 1, 0. Give me another point that's on the x-axis. Any other point that's on the x-axis. 1, 0 total is.
0,
Negative 1, 0.
0, 0 total is.
Negative 1, 0?
Negative 1, 0 totally. What's true about anything you tell me about the x-axis? What point? Something's always going to be true.
The second number is gonna be
Y
0.
is 0.
Yeah.
I love it. Y equals 0 is the x-axis. Could Y be 0 from what we set up? Could Y be 0? What does Y go from to?
It goes from negative 10
Negative
to
10
negative
to negative 2. Could Y be 0?
No, it can't.
So I'm not going to see the x-axis. Because I'm telling the calculator, don't look above negative 2.
It's outside the range.
Is everybody with me? This is just supposed to be a quick aside. What do you think the y-axis is? If the x-axis is y equals 0, the y-axis is
X equals 0.
x equals 0. Give me any point in the y-axis. 0, 7, 0, negative 3, 0, 1. X is always 0. Can x be 0? One in our calculator. Can x be 0? The way we've got it set up. No, because it goes from negative 0.1 to negative 0.5. So when I graph it, it's not surprising I don't see either axis, because I didn't look at either axis. So, when I graph something in the calculator, it's going to graph. So here's the whole picture of what we're looking at. Here it is. This is the whole picture of what we're looking at. This is what y equals 1 over x looks like, a rough sketch. I can tell my calculator to look at any part of it. Right now, we're telling it to look at this part. You guys see that?
You can see the hash marks.
Because I told it to go back and down. So, yeah, okay, enough of that, John. Okay. I just wanted to be that a quick aside. Why can't I see the axes? Because I didn't tell it to look at the axes. Yeah.
I calculated, like, graph that. I think it's because of, like, the bottom. So it comes out like this,
Oh,
but I had it set up.
oh, because you still have squared in there. We're doing the x.
Oh, okay.
Yeah, so now we'll be. Yeah.
My bad.
You're good. All right, so now you guys can do the earlier problem, the one about x squared. That's part of the homework. Anything else from homework stuff?
Oh, 60? The same section.
Oh, that's right. Okay. All right, so let me erase some of this stuff here.
Which unit are you working on here?
This
What's
is
up? Sorry. Oh, this is just homework. Oh, what section is this in?
Yeah,
3.2.
3.3.
It is?
But is the question 63.3?
It's 63.2.
Okay.
oh, I already handed that in.
So you said same section, that's why I stated 3.3. Let's see.
Oh,
Okay. Here we go. This guy?
no, it's in 3.
Oh, okay. That was, okay. I love this book. Hold on. Let me go back to where I was. Real quick, just to point out. See how it says 3.3? Because 3.3 starts here. Yeah. All right, so it is this problem then, correct? The one about the height?
Yes.
Okay. So we're in 3.2, number 60. They give me the function. Can anyone tell me what shape that would have if you did graph it? Yeah, it's going to be U-shaped, but is it going to open up or down?
Down.
Because the squared part is negative, right? If you go into calculus, you'll learn that that is related to the slope, which kind of makes sense. Slope positive go up, slope negative go down. For a parabola, if that's positive, it opens up. If it's negative, it opens down. It is related to slope, which is nifty. So does that make sense that if I throw something in the air, it's going to make this kind of a shape? Of course it does. You've all done that shit. Yes, okay. So this makes sense that this formula would apply to the shape that something would take that if I threw it. Quick side note, that is the actual correct physical number to go there related to the acceleration due to gravity. So this is a valid formula in the real, well, almost the full real world. We're not taking into account wind resistance and all that shit, but don't worry. All right. You have to worry about anything. But give me the function. What's the domain of the function? So this is a physical problem, correct?
Yeah.
When is the ball actually traveling like this? When does it start to travel like this? Immediately after I do what?
Drop the round in the mortar. That's what I did wrong.
Okay, cool. So when does it start to travel like this? Say I'm throwing a ball. When does it start to travel like this? Is it traveling like that while I'm holding it? No, so when does it start to travel like this? When I throw it, okay. And then I'll let seconds go by. So how long has gone by? How long has it been up in the air right before I throw it? 0. Beautiful. So what's the smallest t could be to make physical sense? 0. Are you with me? So if I'm holding a ball in the air, do you guys agree with me that maybe here I am, right? And then I throw it, right? If I go back in time, so let me put it right there. I'm holding it like this for some reason. I go, right? If I try to go back in time, mathematically it makes sense. Isn't there more to the parabola back there?
Sure.
Isn't the real domain, the mathematical domain of this, isn't it negative infinity to infinity? Because there's no issues. Physically, does it make sense to let time go negative?
No.
So somehow the ball started on the ground, jumped up into my hand, and then I just sort of let it keep going. No, that's not what happened. Screw that. So what's the domain start at? 0. Because that's when I first let go of the ball. Now I think you came up with this a minute ago. When does this function stop describing what the ball is doing?
When it hits the ground.
When it hits the ground, which is not at 0 seconds, thankfully. So what do you have to figure out? You have to figure out when it hits the ground. What's true about the height when it hits the ground? It's 0. So 0 equals this, solve it. That's one answer. So to be really honest, the way I drew this is not quite the way the book has this problem. Here's the weird thing about this problem. You ready? I'm going to do something right now, but oh well. Here's the problem. I'm on the ground, and I'm throwing something. Because it starts with at 0, correct? When is it on the ground? You just told me one answer. When is this equal to 0? If you factor this, can't you take a t out? If t is 0, is this 0? Yes, so it starts on the ground. I throw it in the air, and then it hits the ground again. You need to factor this to figure out when it hits the ground. Okay. I like it.
Even if you plug in an extra 0 plus 0, then you factor it. It's still-
Sorry, do it again.
No, that wouldn't make sense.
Yeah, don't make it a number, because then I can't do anything with it. Yeah. Factor out what you can. Set each piece equal to 0. Solve for t. One answer you'll get is 0. Because you can just see 0 would make it 0. The other number I can't just immediately see. If you can, teach me. Right? So you need to factor this so then you can see it.
And then the answers that we have are the domain of the function.
Yes. Because which letter does domain relate to in this function? In this function, which letter does domain relate to? T. Because in general, what does domain relate to? Input. What normally is the input for us? X. What else makes sense to be the input? Time. Okay, so in this case, time is the domain. Okay. I like it. So this is good. So we had a question about something the book really didn't word well. This one is kind of freaky when you first look at it, for sure. Do you guys understand now there's a difference between the mathematical domain of something and the real-life physical domain of something? This is why piecewise functions exist. Because before I take off, the function that describes the plane's motion hasn't started yet, right? So if I take off at t equals 0, t equals -1, doesn't mean shit. The function might be cool with it, but I didn't have my plane burrow through the ground and break out, right? I don't know if they have one that could do that.
Well, you could have a missile silo and then where
Sure,
it
yeah,
hits
yeah,
ground
yeah.
level, it's
Yeah.
like T minus one, T minus, what-
Well, T minus means
Before
before
the
anything's
launch.
happened. So
But
T
it
equals
could
0
also
is
be-
when the function actually
it
starts.
could also mean before it breaks the plane of the
Sure,
ground.
you can define it in all kinds of different ways. Very true. But to me, I'd still say T equals 0, but at T equals 0, the output would be negative because it's below ground. Yeah. All right. Anything else from homework stuff? Yes?
3.3. I think it's one of the first ones.
Where am I at? I think I'm in 3.3 now. Yes.
Like 3, number 5.
Do you not remember the number?
It was 5, yeah.
5? Oh yeah, okay. Okay, so let's review real quick. Alright, so if I ask you, let's do a problem with nothing but numbers in it, right? In terms of the inputs. The one weird thing about this problem is one of these things is a letter. Okay. That bothers us. Yeah. It doesn't bother the process. So what I mean by that? If I give you a function and I ask you, what's the average rate of change? You always do the exact same process. Does anyone remember the earlier algebraic idea that average rate of change relates to? Slope. That's it. It just relates to slope. You with me?
Mm-hmm.
Okay. So of course, slope. What's the most basic formula for slope?
Y2 minus Y1 over X2 over X1.
If I know my inputs, how do I determine my outputs? If I know my x's, how do I get my y's?
Plug in the X.
Plug them in. So if I have a function, if they give me a function, and I know I want to go from x1 to x2, how do I get y2? This is an abstract question, but you all know, you just told me. If I know the input is x2, how do I get the output? Plug in x2, good. So m would be f of x2 minus f of x1 over x2 minus x1. I really want you guys to see that that's just the slope formula, right? Isn't f of x y? So I'm just taking the slope formula and making it a little more like formalized. So if I give us a function, let's say I give us, what do you got, Jeff? 1 minus x squared. And I want to know what's the average rate of change from, what you got, Jeff? 1 to 3. Right, so the question says, what's the average rate of change for this function over this interval? You always do the same thing. Sorry, go ahead.
The same line, you plug 1 to x and then you get the different y.
So what's x2? 3. And what's x1? And over the bottom, you put x2 minus x1. It's y2 minus y1 over x2 minus x1. Still the same exact formula. So we got some funky ass curvy function, and we're just saying, what's the straight line slope between these 2 points? That's all that's doing. Because that is how much I actually changed. So real quick, if I start here, and I go over here, and then I end up right where I started, my average rate of change is 0, because I ended up where I started. I don't know if you guys are with me or not. Okay. Yes.
Don't you have to like plug those numbers into x to go forward now?
Yeah, what is f of 3? So you can actually do this on the side. How do you get f of 3?
1 minus 3 squared.
Yeah, 1 minus 9, negative 8. And what about f of 1?
0.
Yeah, 1 minus 1 squared, 0. So f of 3 is negative 8. F of 1 is 0 over 2, and I get negative 4. So what I I mean by what I just said, if I had a function that looked like this, and I go here, and I go there, how much did the value change? How much did my output change?
None?
None. So the average rate of change here would be 0. The output did not change, did it? I went through some other outputs, but overall, what was the average rate of change? 0, because the output didn't change. Yeah, if this equals this, then that's 0 overall. Yeah. Okay, it's just slope. That's all it is.
There is no slope, it's a straight line.
Say again?
There is no slope, it's a straight line.
No, what's the slope for a straight line like this? What's the slope for this?
0.
0, cool. So 0 is a number. What slope, what line has no slope? Truly, no slope. 0 is a slope. What's the slope for this line?
Oh, there, no.
You can either say it's no slope, you can say it's undefined, you can say it's infinite, right? Huh?
So it's infinite or undefined.
Yeah. So if it's undefined, there isn't one. Okay, I like it.
What I think is kind of weird is that,
How do we do the 5 with this B on the practice?
Yeah, we're getting there. I just want, that's the process, correct?
Yeah.
I'm gonna do this exact same problem, but I'm gonna put a B instead of 3. No, we're
I was
quick.
gonna say, what I think is really weird is that a 45-degree angle is 100% grade. I would have expected it to be straight up and down.
That's not good, okay.
I don't,
100% just means 1 to 1. 1 to 1, 45-degree angle.
I know.
Okay. Now watch this, guys. All right, is everybody cool with this? Every time they ask you for average rate of change, this is what you do. So what's funny is, if I put a B here instead, all right, let's investigate what happens. Do you understand that the process cannot change? The process can't be dependent on what I'm actually looking at. I do the same thing, right? Somebody help me out. What is f of b? Let's just do that again down here. What's f of b?
4b squared minus 7. Or, sorry,
Oh, for this process, I'm not doing the homework.
1 minus 4b.
No,
Or
where's
1
the
minus
4?
b squared.
Okay. Is that cool? If I throw a b in, I'll get 1 minus b squared. Okay. So evaluate at one side. Now what's f of 1? We did that one earlier.
0.
Still 0. So up here I get what f of b is 1 minus b squared minus 0 over b minus 1.
Anything minus 0 is itself. So
Totally.
1 minus b squared
Yeah.
minus 0.
So 1 minus b squared. Now why would you be wrong if you stop there?
You can cancel out the.
Can't cancel shit out right now.
You can just,
Because I have division and subtraction, they don't cancel good.
can't you factor it?
Totally. Isn't that what you do? What do you do? What's the very last step when you get a fraction answer? What's the very last thing you look for?
The common denominator? Or that's the first thing, right?
Can it be reduced? So common factor, right?
Common factor, yeah.
So if you get 15 over 20, depending on how integral that is to the problem, I might either put a note or I might take a point off. Why would I take a point off?
It's not reduced.
Because the top and bottom both has a 5, correct?
Yeah.
You would never write this shit because you can see it, but that's what we do. So here, does the top have a factor that the bottom also has?
Negative b, if you take the negative for negative b plus 1, then you can factor.
So how do you factor the top?
You put a negative sign.
1 is,
Wouldn't you put a negative in front of, oh no,
you could, I'm gonna do it the other way. You could. Yeah, in fact, you wanna do that? You guys wish this was turned around? You guys with me? You can do it at the beginning or the end.
that's how I.
Do you guys know what, do you see what I mean? I think that's what you're picking up on. Wouldn't it be kind of nicer if it was turned around? Have the variable first. You guys kind of agree with me? No.
Your factor, you're gonna be eliminating the denominator.
Let's do it this way. Okay. 1 is 1 times 1. B is b times b. Crazy shit. It's a difference of squares, right?
Plus and minus.
Difference of squares is always easy. Cut everything in half, and then, yeah, plus minus. Does anything cancel directly right now? Is anything the same on the top as it is on the bottom?
Well, if you put a negative in front of the.
Yes, if I take a negative out of this, what happens when I take a negative out of this? That becomes positive b.
Next one.
That becomes
Negative.
-1. Now it is something the same.
Yeah.
Yep. So then this would be my answer.
That's it.
That's it. Now, real quick, when I did the problem earlier with 1 to 3, sorry, what did we get again? -4, is that right? You guys with me? We did this problem earlier, yes? We got -4. And look at what I just got for an answer. If b is 3, what is this? If b is 3, what is this? What's 1 plus 3? 4. -4. It's the same.
Oh,
It's the same answer we got earlier, correct? So by leaving a variable in there, we solved an infinite number of things at once. Because now you can make b whatever the hell you wanted it to be. What if I wanted it to be a 5? Well, then the answer would be -6. That's the power of using variables instead of numbers. You're doing it to every possible thing. Okay, maybe. So this process is always the same. y2 minus y1 over x2 minus x1. Same old slope stuff we've done before, except now we're going to write it better. How do we get y stuff? Well, we plug the x stuff in. Let's do another one.
You do one with all letters.
With what now?
All letters?
Is there one with all letters?
Yeah.
Which one?
10.
Oh, I see, okay. Yeah, let's do one like number 10. Yeah. So let's see, I've got, what do you got here? 2x squared plus 7. And I want to know the average rate of change
When the average change
on, sorry?
When the average change automatically implement the slope for it.
Slope, totally.
Got it.
X to x plus h. Real quick. Whatever that number is, that is h more. That's very unsatisfactory, I understand. But these are just my inputs, correct? That's all they are. So how would I figure out the average rate of change? What do I put on the top?
F of x plus h.
Good, f of the second dude,
And then minus f of x.
good. And do I know this?
No.
Do I know this?
Yes.
Yes.
2x squared plus 7.
I love it. Do I know this? Not yet. You guys see that? All right. So in mathematics, you have a process. The process requires stuff from you. You can write the process, step back and go, what do I know? What do I don't know?
So you could plug in 2x squared into the first one too, but without it plus h, right?
Well, I think you're saying it backwards, but I don't know if you mean it the right way. What goes on the bottom?
Oh, yeah.
X1
Plus h.
Yeah, the second 8x minus the first x. So what happens there?
Got it.
So it's just over h.
Just h, okay. Is everybody with me? And again, did the process change at all? F of the second dude minus f of the first dude, second dude minus first dude. It's always that. Why is it always that? Because slope is always y2 minus y1 over x2 minus x1. That's how we defined it. So it's always that. The only thing I don't know in this entire statement is this. So let's figure it out. What is f of x plus h? What am I putting into f?
X plus h.
X plus h. So what am I replacing x with?
Of x plus h.
X plus h. That's the single-minded nature of functions. Whatever's inside of them, you put that into it, right? So I'm going to put this here.
Why is parentheses?
You stop, yes? Sorry.
Why is it in parentheses?
Do it, I'm sorry.
Why is it in parentheses?
Oh, okay. Help me out real quick. You ready? Couple quick questions. If this is all side note, yes? What is f of 3, for example?
9 times.
Yeah, it'd be 2 times 3 squared plus 7. Is that cool?
25.
Yeah, so it'd be 18 plus 7, 25. You guys with me? And you're sitting there like, that didn't answer my question at all, Jeff. Thanks, man. It's like, sounds like a math teacher. Okay. What about this? What is f of negative 5? How would you write that down? 2 times
Negative 5 squared.
like this? Does
No.
that make sense?
No.
Nope.
Gotta put it
There.
back.
Because what's the function need me? I know I didn't finish. I don't care. The point's done. What's the function need me to square? Everything I put into it. So what am I putting into the function? X plus h. So what am I going to square? X plus h. Is that cool? And again, please don't take me wrong. That is a very understandable misunderstanding to have, because we're used to having single things to throw in. But even when I have a negative 5, it only makes sense if I write it with a parenthesis around it, because I got to square the whole negative 5. So here I got to square the whole x plus h. So that tells you what to do next. Because I can simplify this, yes? What do I have to do next?
Factor.
Do I distribute the 2?
No.
Hell no, because that's below exponents in the good old order operations. So what do? I have to do,
X squared. Or,
right? You can write it twice, because that's what the hell square means, right?
Yeah.
So then I square that out, x squared plus hx, so plus 2hx.
plus h squared.
11, and then plus h squared. So then I get 2x squared plus 4hx plus 4h squared plus 7. Because I distributed 2. Why did I do 2 times 7?
Because
It's 9.
Because 7's not in there, right? 7's not being doubled. Okay. Why did I do all this? Why did I do right here? Why did I do this?
To figure out what f of
Because the problem needs me to know this, and do we know it now? Yeah, cool. You guys see that? So again, this is what I call the construction approach. If you write down what you need, go get what you need, right? I need this. I got it. I need this. I got it. I need this. I got it. I need this. Oh shit. Let me make that. Now I can throw that in. Yes. Sorry. Yes. So you're cool up to here?
2.
And then you double, you bring the 2 in, yeah? Oh, 4, thank you. That should be 2. Yeah.
So we can assume that 4h x plus 2h squared is plus h on the top of the problem.
No assuming.
No, so
No assuming. I don't have to assume anything. So everybody agree that that is the solution. That is the answer. Because that's what we do to figure out the average rate of change. Does everybody with me?
So with that.
Now.
That's not the answer, is it?
No. That represents the answer. Now, what is f of x plus h? That. What is f of x?
0.
2x squared plus h.
Yeah. So again, I'm gonna make a mistake. I've made a mistake. What mistake did I just make?
You put the parentheses.
I didn't subtract the whole function, right? This is minus this whole function. And of course the bottom, like you said, is h.
Wait, why is it just h? Because the x.
Help me out. Are you cool with x plus h minus x? Yeah, so the x's cancel, yeah.
A lot of steps.
No. A lot of steps would be if it takes 7 pages to do a problem. Yeah. Yeah, yes. And more than that. Good God. And I was always the one that had the smallest stack, because I always try to do it the most efficiently, you know, like everybody else is turning all this shit. But, yes, compared to some other stuff you guys do, sure. But really not that much. What can happen up top? What cancels up top?
2x squared.
2x squared minus 2x squared, what else?
7.
7 minus 7. So then what's left alive?
4x8.
4xh,
2h squared.
2h squared.
And then you can just factor h out.
So I can kill an h, yeah. And I like the way you said it. To be really careful, you can factor an h out, and that h dies. But if you don't factor, you got to kill an h in each thing, because they're both being divided by h. right? So then that's my answer.
So,
Really unsatisfactory, right? But everything we just did is algebra based, and everything we just did is something you will do in calculus. And then you'll do the next step will be actual calculus after this. There's one more step after this that you would do. And what that actually would find, why is it hard to figure out the slope of a parabola? Why is it really hard to figure out the slope of a parabola versus a straight line? The slope for a straight line does what?
It's infinite.
The slope for a straight line does what? Stays the same. Slope for a parabola, it's negative, correct? You with me? That's a negative slope.
That side, the left side.
And then it becomes 0. And then it becomes positive, getting bigger. You guys with me? You guys with me?
Yeah.
I know this is beyond our class, but we can all handle this. Isn't the slope for a parabola always changing? Oh, that sucks. That's why it's its own class, to talk about slopes of curves. Do we have to know any of that right now? Nope, because we stop right there. Okay.
Basically, just straight algebra.
Yeah, that's crazy. So I always do this when I have an average rate of change problem. I always do this. Just does it suck when there's stuff that's not numbers? Yeah, because we're used to work with numbers, but I do the exact same thing every time. Okay. All right. I want to work towards something. Anything else from homework real quick? Okay.
40. Question number 40.
In the same section,
Yeah, 3.3.
section 3.3. All right, let me see, what's it say? Use a graphing utility for the local stream of blah, blah, blah. Okay. So here's number 40.
What's the, what is the question?
Sorry.
I don't know.
Use a graphing utility, like a graphing calculator, to estimate the local extrema, the max and min.
Sorry I wasn't here for the first day of the class. Do we need to have a graphic calculator or the prior power?
Yeah. You got the syllabus, right?
I skimmed it.
Huh?
I did skim the syllabus.
Oh, okay, okay.
Specifically.
It's crazy how much it's in there.
Yeah.
I do have a show your work shirt. I need
I
a.
looked at the homework sheet, like.
No, you're okay, man. I'm sorry.
So by Wednesday, we should have the graphic calculator.
Yes. And again, just reminding guys, you can borrow one from the library. I think it's a week you can borrow it at a time. I'm not sure. You can borrow one while you're in the Math Study Center. You can rent one from that website that's on the syllabus. $30 a semester. You can go buy one. Right? And I will have a coat of my bag of calculators with me. Just don't bank on one of those because I might not have as many as people need. So do as much as you can to get your own. Yeah.
Yeah, so,
Okay. Yeah.
You can usually find them on Opera for like
Yeah.
or half off.
What is that one?
I
Like
heard on
offer up? or-
Offer Up? Is that
on
a
Amazon, they cost.
community?
It's kind of like an
It's a
eBay.
modern Craigslist.
Yeah.
Modern Craigslist. Okay.
Yeah, or I heard on Amazon, they could go down to like less than 25. That's what I heard.
Yeah, you could find
Yeah,
it for relatively cheap. Yes.
Totally not related to the subject, but.
I love it.
Can you go over the test review with us, or do we have to get that?
No, so tomorrow I'll have the answer key for that.
Okay.
so tomorrow's just review.
Tomorrow's just review day. Yeah.
Oh, good.
Cool. So I'm not gonna just throw that at you and say,
No, good luck.
because then it wouldn't be very useful. Yeah. So I'll have the answer key all for tomorrow, right? If you don't have any time to do any of the practice tests, that's okay, really. I mean, you don't have to turn the sucker in. But you can at least just glance at it to see the way I kind of set things up, because, you know, every teacher kind of sets things up a little different, yeah.
Is that on the test?
Yeah, totally.
Do we need-
Of course it is. Huh?
Do we need any sort of, hands-on for the test?
Real quick, guys, have I said this yet? If you have a math teacher that needs a Scantron for tests, they are not a math teacher. Because what is the most important thing for a math teacher to put eyes on?
Your work.
Your freaking work, right? Because that's your thought process, and that's what I am here to help develop. Correct? Not because I'm amazing, because I just know math. I don't know other shit. You guys could probably teach me a lot of shit. each of you. I just happen to know a lot of math, so yay for me. So if I don't get your work, I can't help anything. I'm sorry.
No, that's fine.
You're fine, because I know you've probably had other math teachers that did Scantrons, because they're lazy bastards. But yeah, huh?
I'm not from Manchester. Well, we did a quiz on Friday. I went to the class.
Okay, you're good. All right. So what's the current question? I'm sorry, I got sidetracked. Is there a current question?
It was 40.
Thank you. Okay. Okay. So I'm pretty sure we did this, but let's do one problem like this. Let's do number 38, just to get one like this. I'm gonna put that in the calculator. Bless you. Now, real quick, the calculator doesn't give me a t variable by itself. I'm just gonna use x exactly because it doesn't really matter, it's just a dummy variable. How do I put
What
it?
number is this again?
Sorry?
What number is it?
Oh,
It was 40.
I'm just happening to do number 38. The actual question is 40. So 40 has got more shit to it, yes? But you do the exact same thing I'm about to do. Right? You think, is that gonna have, let's see. No. Yes, it will, okay. Alright. We've done intersections of two equations. We've definitely done zeros, like finding the x-intercepts. Remember that where it said left bound, right bound, guess? It's possible we haven't done max and min, but I thought I did. Let's see. So it's 3x to the... Now I have one of these nifty calculators where it just goes up for my exponent. If you don't, if yours has a little caret, when you hit the little caret button, and it just has a little caret, you gotta put 2/3 in parentheses. Because the calculator doesn't have eyeballs. It doesn't know.
How did you do it on your calculator?
Okay, so I did, my calculator's nifty, so I do 3, there's my X button, then to the, there's your to the button,
Okay.
and see how it just goes up?
Okay, yeah.
2 divided by 3. If yours doesn't go up, and let me see if we can make mine not go up. Give me a second. I think this will still do the same thing, let me see. Oh, there you go. If yours looks like this, right? If yours looks like that, when you do the to the, you've got to put 2/3 in parentheses. No, Jeff. You guys got it with me? If you didn't do that, if you didn't put in parentheses, it would be 3x squared divided by 3, not 3x to the 2/3. And I kind of like the fact that my calculator does not have eyeballs. That would freak the shit out of me. But because it doesn't, we have to tell it, oh, calculator, you can't see shit. Let me tell you that's in the power. Are you guys with me? Okay. 3x to the 2/3. No, I already forgot what the hell it was.
Minus x.
Minus x. Is it minus x?
It's minus t. But
Oh, it is minus t. Oh, good. So then that does some neat stuff.
yeah.
Okay. Okay, so read with me. Now watch. I'm going to hit the graph button, and I'm not going to see much of anything. I'll see a little bit. Maybe. Let's see. Nope. Why don't I see anything?
Because of your window.
I made my window all different for the earlier problem. Remember that? So, does anyone remember I hit zoom 6, zoom standard to get back to a -10 to 10, -10 to 10 window. So I could just hit the number 6. I hit zoom and then the number 6, and we should all have this.
That's a shame. I would like.
Isn't that funkadelic? No? You guys know what I got. Did you expect that? If you didn't, it's okay, because it's got fractional powers and such. It's going to be a little weird. It's the squared part that makes this freaky. It's to a 2/3 power, so it's got a square in it. So it takes what would normally be down here and it puts it up there, which makes it look weirder than it normally would. Okay, David. What am I trying to find on this problem? I'm not having a senior moment, I remember. But what am I trying to find? Anybody remember? Trying to find the min and the max, right? There's an obvious min. Do Do you guys agree with me?
Yes.
In fact, I don't even need to do the work in the calculator. What's the min?
0, 0.
But let's verify that. See if this calculator can handle this. By the way,
That's why you use the graphic calculator, because then you can see.
yeah, because can anyone see the max? There is a max. There's a local max. Can you guys see it?
Yeah,
It's
it's
the
three.
top of that.
Do you see how this goes up and then it comes back
Oh,
down?
yeah.
Do you see that?
Like
So the max is somewhere in here. Do you guys see that?
Yeah.
Do you guys see that?
Yeah.
Yes.
Or the max,
Mine
that's
does
three.
not look like that.
Oh, you probably didn't put. Oh, because you're like on a major window. Okay. So again, hit zoom. 6. Are you good?
Yeah.
Alright. Real quick. If I wanted to see further out, what would I change? If I want to see further up on the x-axis, what would I change? Why currently does it stop at 10? Hit window. What do I change here to see further up? Yeah, if I want to see further up, let's say I want to go out to 100. So now in a graph, it's going to go much further out. Look at that weird thing. Now can you really tell there's a maximum?
Mm-hmm.
Yeah, because once I zoom out, I can totally see the top of that hill, right? You guys are all with me? Yes.
So we're looking for a local minimum and a local maximum?
Yes.
Okay.
So it makes nothing but sense that locally that's a minimum. If I go further out, do you guys agree that it gets lower?
Mm-hmm.
But locally, that's a minimum. Locally, there's a maximum in here somewhere. There's a valley and there's a hill, yes? The valley is weird as shit, but do you guys see that? So I can have two separate things. Again, I'm an absolute max, which is the absolute biggest and an absolute min. And I have local mins, local maxes. Is this an absolute maximum? Doesn't it get higher? So this is not the biggest, but it is a local big, right?
That's positive.
It's kind of like winning regionals, but not
Nah.
national, right? Okay. Does that make sense? Okay. So let's do this. Let's find this maximum. So I want the calculator to calculate something graphically. What controls graphical stuff with the calculator? Which part of the calculator is the graphical stuff?
Trace?
No, there's a whole section that's all graphical stuff.
Oh, fine, but
All this
Oh,
whole
just
first
the
row, you guys agree with me?
Yeah.
All this is graphical stuff. I want to calculate something graphically, so where do I go? Second trace, see the calc. So if we hit second trace, what do I want to calculate right now?
Minimum?
No, I want to do the maximum. The minimum you can see is 0. That one you can see. Let's do the maximum. And it's going to ask us 3 very familiar questions, right? So the way I tell students to do this is I put the cursor on the answer. So it's somewhere in here, right? Maybe right in the middle somewhere. Are you with me? Then I go to the left a little bit, enter. Go back to the answer, go to the right a little bit,
The highest one. Right?
enter. So that's the left bound and a right bound. I give the calculator somewhere to search. And then I go to my guess, enter. So what is my maximum output?
4.
4. Beautiful. Where does my maximum output occur? What do you think this is trying to say?
8.
It's trying to say 8. You with me? Do you see
Yeah.
that?
Yeah, at the point.
I'm pretty sure it's trying to say 8
If you
here.
went to table, it would say 8.
Yeah, if you went to table, it says A11. Okay.
What about on the left? Left side?
What?
Or are we talking about-
Oh, yeah, we can do the entire process again here, except then I want to pick minimum. Is that what you mean?
No, the line that goes on the left side, the negative x side.
Oh, this here?
Yeah. Are we required to do that?
How far up do you think that goes?
Oh, to infinity.
Yeah, so there is no local maximum.
Gotcha.
It's like the sky's the limit. No, it goes past that. Okay, all right. Do you notice how so many calculator processes require a left bound, a right bound, and then a guess? Why does that make sense? Because the poor little calculator has infinite to consider about. It's like, holy shit, it's gonna. So then you give it, no, dude, it's somewhere between here. Here's where I think it. So then it can do its little algorithm and find it. And if you take calculus, you will learn one major algorithm the calculator uses, which I understand is not like that enticing for a lot of us. You're like, I can live without knowing that. But if you do, you'll learn it, which is kind of nifty. Okay. Oh. So we're gonna at least, yes?
Unrelated to this, is there a difference between Python and the non-Python version?
Oh, this just means, I don't know if you know the computer language Python?
Yeah.
Okay, so this means that some of its processes are built on Python. So it's more efficient, huh?
Coding?
Yeah, say again?
That's coding?
Yeah, it's a coding language. It's like C++ and all that stuff, yeah.
So it's just more efficient.
More efficient. Yeah, it's another improvement. So we improve the hardware and we also improve the software. Yeah.
But there's no fundamental difference in that.
No, I mean, in certain extreme answers, you can get more precise answers,
So it
but
doesn't matter, it doesn't matter if you get a Python or online. version.
no, hell no.
But these you have to charge, right?
Say again?
These you have to charge.
Oh yeah,
Yeah.
yeah.
But they
Yeah.
last forever.
They don't live off of like love.
Solar.
I love your calculator. Oh,
You
it's
have to
charged.
charge them, but their battery lasts so long.
Okay.
Alright.
All right. Okay. All right. So, I need you guys to. All right. Let's talk about this for a minute. Obviously, class is almost done. I'm still gonna have the test on Wednesday, and I am gonna include transformations on the test. So we're gonna finish that right now, and so that means through 3.5 will be on the test, right? I'm sure that's. So we didn't quite get into the full thing about absolute values. So let me talk about transformations. I'll tell you which parts of the practice test are not applicable. Does it make sense? Some of that won't be applicable since we're not going to make it as far as I thought we would, which is fine. These things happen. Oh, there you go. Okay. Which one of you is good? I don't remember. Let's just use you.
You still want us to complete homework for 3.6 and 7, though?
Those will be on the next test, including 2.6, right? So our test is gonna go up through 3.5. You guys all with me? Alright, so the test will be Wednesday through 3.5. What that means is 3.6, 2.6, 3.7, that homework will be due for the next test. Does that make sense? I'm never gonna make homework due that isn't actually on the test. That wouldn't make any sense. I want you focusing on the homework that's for the test. You guys all with me? So if you're done 3.5, you're like, done. Yay, now you can focus on the practice test. Okay. So real quick. Can anyone tell me what the shape of this is?
It's called an eyelash or whatever.
Okay, sure. Eyelash, I can see that.
So,
So it's basically this, but let's be a little better. So 1 goes to 1, and 4 goes to 2. So there's the shape of it. So what I normally ask you to do for these kind of problems is, I'll give you a function, I'll say list the transforms, graph the base function using the transforms. Or, I mean, graph the function using it. So if I give you this function here, let's just do one we've already done.
Professor,
Yes.
can you turn the camera away?
Oh,
so
yeah,
we can-
thank you. I need to hire a camera person. Got a few things happening at once. Can anyone tell me, do you guys remember which way that's gonna move that graph? Left. Why, real quick? That says plus, correct? So some of you guys are like, what the shit? But again,
The X value.
real quick, huh?
It's in the.
It's in there, yes. But if it costs $10 to get in a club and I only have 8, but there's a dude at the door that's gonna give me $2, I can still get in, correct? If I have $8 and it costs 10 to get in, and there's a dude at the door that's gonna give me $2, can I still get in?
Yeah.
Yeah, because then I'll have 10. So all the inputs can be 2 less than they used to be, because the first thing I do is give them 2. So I gotta have 2 less bucks and still get in, because there's a dude at the door that's just giving away money for some reason, right? That's me if I win the Powerball or something. There you go. Need some help? There you go. To a point. Now, so this, if I list the transforms, there's just 1, left 2. That's the one thing I see in this. How is it different from the square root of x? Got that in there, and that's going to make it go back 2. So if I just go to my base graph, so the points I use for the base graph for this are 0, 1, and 4. The inputs I use. That's the base function. What do I do with each point?
You move it to the left.
Yeah, so I take this point,
We only use the X point for left.
real quick. I'm not sure what you mean by x points. Now, why am I going in the x direction? Because x is left and right. When I want to go up and down, if I had something that was outside, that would make it go up and down. So I'm going to take that point back 2, that point back 2, that point back 2, and then put the line. How do I check that answer? What point is this? 2, 2, right? When I put a 2 in, what do I get? 4, what's the square root of 4? So when I put a 2 in, I get a 2 out. I look good, right? I mean, my answer looks good. I still look a little rough. Okay. You guys all with me? Okay, nothing too major there. The one thing we didn't look at, so what would happen if I put a +1 outside? What would that do to this picture? Every point would just go up 1. So then my list would look like left 2, up 1. So I would take every point back to up 1, back to up 1, back to up 1, and then I would just fill in the graph. Okay, so those transformations are really straightforward. What about this? Let me see, how much do you want to blow you with? Let's just do this first.
Move downward parallel. Or downward line.
Say again? Yeah, so you're both kind of right. I know what you mean. You don't mean line. It just flips.
Yeah.
The square root picture just flips. So here's the square root picture, right?
Yeah.
That's the base function, and now all the outputs just become the opposite of what they used to be. So if I graph the base, so what's the transformations? Reflect around which axis? X-axis. And again, real quick, if it's outside, it's up and down. So isn't flipping this flipping it down? Okay. So now I would take the base graph. And I would flip it, so I would make this dotted, so I know it's a base graph and not the answer. And then I would just take every point, flip it. So if I negate this, I get 0 still. If I negate this, I get -1. Wow. If I negate this, I get -2. Wow. So then this is the answer. And that's the other half of the parabola, yeah? Say again? Okay. Everything we just did, it would be all the same transformations. If this was actually this, what would the transformations be?
Yeah, negative for
Left 2,
parentheses.
up 1. Same freaking transformation. Transformations don't give a shit what the function is. But the shape we make, that we move around, is based on what the function is. Are you guys kind of with me? So we go left 2, up 1. So I'd start with a parabola. What time is it? Almost. You got time. I start with a parabola base function. And now I would take every point left 2. So this point here, I would take it left 2, down 1. I'm sorry, up 1. Left 2, up 1. Left 2, up 1. Left 2, up 1. And then I would just regraph And how do I check that? I pick a point, plug it in, see if it works, yeah.
So if I have -1, it would be that 2 down.
Down one, kick ass, right? Because look at this, whatever the shit that is, whatever output that is, isn't that one bigger? So graphically, that just means lift your graph up, right? Lift your graph up. Now, real quick, last thing. What if instead it was square root of negative x? Does anyone have a problem with that?
That,
Is that okay?
It goes this way.
Is it outside? If it's outside, it's up or down. If it's inside, it's left or right. So what kind of reflection is this?
So
Around the y-axis, it's the left-right flip, right? Because is it inside? Yes. Before, could have put a negative number in and have it come out real.
No.
What's the square root of -4? Is that real? No. Now can I put a negative number in? Because what's the very first thing that happens to a number? I change the sign. So in fact, not only can I put a negative number,
You must.
I have to put a negative number or 0, correct?
Yeah.
So this whole picture then, that used to look like this, just flips this way.
Yeah. Mhm.
So this flips, this reflection just stays there, it's on the mirror. This reflects here, this reflects here. So now it looks like this. Let's check it. What do I get when I put a -4 in?
4 or 2.
Square root of -4, square root of 4, 2, check. So when it's inside with the x, it's left, right, including flips. That's awesome. When it's outside, it's up and down. Move it up and down, flip it up and down. That's kind of beautiful, if you let it be. Oh, it's beautiful. Double rainbow. Okay. All right, so we made it through section 3.5. Your only homework for this Wednesday is through 3.5. 3.6, 3.7, all that stuff is still going to be on the next test. We're not going to just skip it entirely. But you don't have to do that homework yet. Anybody not get the web anymore? If you didn't get the practice test, let's see, you might need to email me. Oh, sorry. Abdul Asia, coming up here. Jocelyn. Oh, Asia. Abdul, Jocelyn. Oh, Asia, there's more here, sorry. Vivek. Noah. Jacob. Jacob. Hey. Mike. Peyton. Oh. Brooke. Elena. Elena and Raul.
I made a mistake, I did the first one.
Yeah.
I
Here's the major problem I'm gonna have with this. I'm gonna need to bring this. I've got to see some more. Yep.
How do you,
How the heck do you get that?
I have to do it in my head.
Alright, show me what you're doing in here. You're doing stuff in here, correct?
Yeah.
Can you write down what you're doing?
Yeah.
Okay, you, do it.
And the last question, I don't understand, I have to do it.
Yeah, this one we did a few times. But you missed it, of course. Let me see.
So, and where